Every day you log into your favorite apps, and that works just perfectly. And you go to my YouTube channel, for example, and the content you see is different from the content I see. Well, if you want to learn how to do that, stick around, because this is what we'll be covering. Welcome back to my channel. So for this tutorial, we will also start with the applications architecture to have a better understanding of what's happening. Last time we said that users make requests via routes. So if someone wants to log in, they have to reach out to the login route. It will take them to the controller responsible for login. And if that controller needs some data, it is structured here in our module, and they retrieve it from the database. Now, this is simple, but this is the base architecture for almost all apps. Since we have created this in the previous tutorial, we can build on top of it to create the authentication parts. If you did not see my previous tutorial, that's fine too. I will cover most of the concepts, but for better understanding and details, you can check it out. This is somehow the application's modularity, how the folders will be structured. Now let's say we have multiple routes. These days, most applications do, in fact, but not everybody is allowed to access everything. Usually, admins, for example, have more privileges than normal users. And so, to control this, we are going to use our middleware. The middleware needs to see some kind of a ticket, which is usually referred to as a token. I am sure you have heard of it before. And so our token is our pass to access a route. We can compare this situation to a person that's attending a concert, and the middleware is the guard that needs to check the validity of the ticket. So in this analogy, you are here and you want to go to your concert room, and this is our guard, the middleware. They will check your ticket. So you have your ticket, your token, the guard will look at the details on the ticket, and so in the IT world, we call those details claims. It's just a fancy way of saying details. So they will check your identity, if you are authorized to go, etc. They will also check your ticket's validity. Maybe it has been used before. Maybe its date has expired. And this validity is often done via a key. And that's exactly what we will do in our app. We start with the usual: init our project, create all folders. So routes, middleware, controllers, config, modules, and helpers. We create the router R using Gin.default. It's going to take us to our routes, which will be created under the function setup_routes. And we run the server with .run. And we add the port. Let's print that out. I like to bring the environment variables from an env file for better security and modularity, but here, if you want to type your port number, and your main function will just work the same. So the last thing we talked about in our architecture is the key. There are multiple ways to do that. Usually it's randomly created by the system, its value is then stored in the env file and you export it. But I also wanted to show you how to generate a random key in here. So we will create the generate random key and call it, and then reset it using this set function. In the routes, setup routes take router, then we create two simple post routes, which are the signup and the login. These are usually public routes because they are the entry point to the app to create an account or to log in. But then, after creating your account to access the rest of the app, you need to be authenticated. That's why we create a group of protected routes. Which are get users and get user. These are just examples. And here, let's tell the program, well, I want to use the middleware for authentication. We import our function in main. The routes look good in here. The logic was simple and represents what we have talked about in the beginning. And we let the controllers take care of the business part. Now let's create the authentication. All our controllers, including this authenticate function, return a handler function. Calling a controller and you add the parentheses, it means you're calling the function, and in Go, a function can return a function. So we return that, which takes a Gin context. Your authentication info are present in your header. That's why first thing we do is extract them. If it's empty, well, simply you don't have authorization. Now, an authorization looks like this. There's the word bearer, and then the token value, which is a string. Since we only want to work with the token, let's remove the bearer part from it. Now that we have our authorization in the proper format, we need to extract the claims from it, the details. For this, we are going to use a function, which we'll create later, called validate token. And this validate token is going to return the claims and an error. It takes the authorization header. So if the error is not nil, it will log that. And we will also give a status unauthorized and print out the error invalid token. Then we're going to abort. But of course, if we got validated and we have our claims, we set that using the claims we retrieved. Then we are going to pass those claims to the next handler function. Because this authenticate is at the middleware part. We authenticated and got the claims, which will be used in the protected controllers. Okay, so authentication is done. You see, it wasn't very difficult. Now, there's this validate token that we need to create. So let's go to our helpers and add a new helper. We can go ahead with the authentication, but I think it's better to start with the model first to get an idea about what data we are working with. Our data will have a lot of fields this time. It will surely have an ID, the first name, a last name. It needs a password, of course, an email and a phone number. We also need to store the token. Since we want different roles, an admin and a normal user, let's have this role field. We are also creating something called a refresh token. So the difference between the token and the refresh token is that the token should expire rapidly in order to keep our app secure. But if the session expires too frequently, this means the user has to log in multiple times. It can be annoying from a user experience point of view. This is why we create the refresh token. Token and refresh tokens expiration dates will be depending on the users, so we need to add a create that and updated that fields. ID is certainly of type bson. It can't be empty, so we add this armored empty. Let's go get the Mongo package. Almost all our fields are string, and created that, updated that are of type time. If you found this syntax strange, you can check out my video about working with JSON. When we add validate here, it means to insert this in the database, a validation has to be made, including the field is not empty and it has at least 2 characters. We will do the same here. You got the idea now of what this validation means. We will also do that for the password. Now for the email, when we provide this email tag, it also checks for the email format, so someone can just type in anything in here. The token shouldn't be empty either. Role is required, and it also has to be either an admin or a user. Make sure here the only spaces you have are between these double quotes and validate, because it can cause errors when during compilation. Okay, so our model looks great, our data is consistent and protected. Now I think we can go back to our token and work on it. So when you're creating an account for something, you don't always need all the information to be able to log in. Mainly you use your credentials. And that's why for our claims, let's create a new type here, claims. In here we will just get the needed details that will let us authenticate, which are the user ID and the email, but we also need a role this time. And to tell the application that these will be used as claims, we just add the JWT standard claims, and let's get this from here. Okay, good. So this will return a claim structure and an error. Now we said to validate the token, we use some kind of a key. So this is why we will start by retrieving that secret key. The secret key in our main app was created as a string, but we need to work with it as an array of bytes. By using the set JWT key and get JWT key functions, direct access to the JWT key variable is avoided. This allows better control over how the key is set or retrieved, reducing the risk of accidental changes or unauthorized access. Using JWT parse with claims, we parse the token string, validate its signature using the provided key, and decode the claims into a specific structure that we just created earlier. So if the error is not nil, that means we couldn't get the token. So we don't need to return any claims, and we will return an error. Now, if the token is actually valid, we can return those claims, and nil because we don't have any error. But if the claims here or the token were invalid, we don't return any claims, and we return an error for invalid token. Okay, so our validate token is now ready. What we can do right now is go implement the generate random key. So let's do that here in config. There are a lot of algorithms to generate keys. We will just use a random function, rand. We handle the error. And return that encoded in base 64. We can also go set up the connection to the database and create the function that will open the collection. I will fast forward through this because I have made this detailed video about setting up a MongoDB connection. So if you want to understand exactly how this works, you can find it in this video, or you can also get the code from the GitHub link below in the description. Everything is well done. Now we are ready to start our controllers. So let's start with the sign-in controller. Let's open the connection. Defer cancel to prevent memory leaks. Okay, so to sign up a user, we create a user variables. It has our model type, and we fill all those fields. As a user, when you sign up, you're going to write some inputs. So let's get those using the byte JSON. It returns an error, and of course, if the error is not nil, we are going to return a status bad request. Remember when we have written our model, we used validate a lot. That's why in here we instantiate validator object, which provides validation functions for the struct fields based on those tags. And the use is very simple. We're just telling, do you validate the input that was given by the user? As simple as that. This returns an error, of course. We will also return a bad request. Okay, great. So the user could have imported correct form of data. We want the email and the phone number to be unique so that the user doesn't have multiple accounts. And what we can do is go to our database and count how many of that email and phone number exist. And of course, if we have more than one, then we have to also return an error. For this, of course, we need the user collection, and we have created an opal collection function in our config DB. Let's make it global. We will probably need it a couple of times. If we encounter an error while counting, we handle the error and return it. And if the count variable is greater than 0, I also return a bad request and tell the user that this email or phone number already exists. The rest of the data needs to be manipulated by us before we store it. First thing to do is to hash the password. Hashing the password means changing its appearance so no one can see it even if they have access to the database. That's the hash function we will create. So if this is the first time the user was created or updated, we just give it time.now. The user ID will be assigned automatically by MongoDB. For the access token and the refresh token, we are going to create a separate function that will create those based on the user email, user ID, and role. I may have repeated this a lot, but tokens are generally string. This is why this function is going to return 2 strings. But if you look here, token and refresh token are pointers, so we assign their addresses. Now that we have formatted our data, let's insert this in the database, in our user collection, of course. Insert one is very straightforward to use. It also returns an insert error and an insert result that we don't need. So we need to check if the insert error is not nil. This means something happened. But if everything is okay now, we can return a status OK and say that the user was created successfully. Okay, this is nice actually, not too difficult, and we can go create our hash password and our generate token. They will be here in the helpers. I will start with hashing the password because it's a very short function, actually almost predefined. We are going to use a bcrypt library to do so. The password was hashed in bytes. Let's make it back into a string and return that address. And this is it for hashing the password. We can go now and dive into the token generation. So we said that our token will be based on the email, the user ID, and the user type, which are all strings, and it is returning 2 strings. So to stay protected, our token shouldn't last more than 24 hours. But we can go up to a week for the refresh token. Let's get our claims and add to them their expiration date. So the email is email, user ID is user ID, role is user type. And here we add the expires at and token expiration. Now that we have everything we need to actually generate a token, we will use a predefined function. For the access token, we use the JWT new with claims and pass our claims. But also I have mentioned that a token needs to be signed by the key to be valid. So we also use an existing function and pass our JWT key. We will do exactly the same thing for the refresh token, but instead we will pass the refresh claims. So to create a token, we need the email, the user ID, and the user type. We also need an expiration and use those claims to generate a token string. We authenticate the token using a JWT key, and then we just return that back. Very good, our sign up is done. We can now move into the login. So the idea behind the login is that we have the user data and we need to find a user that has the same data in order to allow them to log in. So these two will be user models. Let's get our user input. So if everything is okay, let's try to find a user that has the same email and store it in the found user variable. Now what we need to do is to compare if the found user password and the given user password match. This is why we will be using another helper function called verify passwords. The verify password will return a boolean and a message saying if the user password is valid or not. If the password is not valid, then let's return a JSON non-authorized and the message. After the sign-in, we should update all the tokens using the update token, another function we will create. It will get both tokens and the user ID. So if everything is okay, we will have a status okay. We can return our user and also the tokens. And our login is done too. Mainly what we do, to sum it up again, is that we try to find a user in our database that has the same email and password. and we compare the two passwords to make sure it's valid. Then we update the tokens, and that's it. We can now go on to create the verified password and update the tokens. Okay, so actually updating the tokens this time is kinda easy because tokens already exist. Let's get our user collection. In here, we will use something called an update object. It is a specific MongoDB object. When we create this update object, we only mention the fields that we want to update. Any field not mentioned will just stay the same. We have used the .update one a lot of times. If you can see, it has of course a context, but also we give the filter and we give the updates. We have given the updates in line in a lot of times when it's relatively simple, but now I have created the updates separately and I'm going to create the filter separately too. We will filter based on our user ID because it's unique to each user. Yes, we can find the user. It returns the update result in an error. We don't need the update result. We just have to check if there are any errors. Okay, we can go to our validate passwords now. Verifying the password is even easier than hashing the password because we are using the bcrypt package that has this comparison. We said it's going to return a boolean and a message. The only thing you have to remember about the bcrypt package is that it only uses bytes, so you have to convert the password from string to bytes every time. So this is a boolean that it returns if the error is nil, and it should be nil. This means this is true, so it's good. And if not, it returns an error. I have a typo here. Oh, and we did not handle the error around here. Yeah, so if we can't find the user, return not found. Now let's go get the users. The first thing we need to do in here is to retrieve the claims from the context. Because these two routes can't be accessed without having a proper authorization, which is in the claims basically. So let's use the get claims, and this is what it does. If there are no claims, of course, that means the user is unauthorized, and we return that. To easily work with these claims, just like in the helpers, we put them in the type struct. If there's an error, let's give invalid claims. So in the logic we want to create, only admins can get the list of all users. This is why we check for the role. But it's easy since now our claims are well structured. So if it's not an admin, it's unauthorized. Okay, now we know it's an admin. We just get a list of all users like we should do in a normal CRUD. This is exactly what we did in the previous tutorial. The main focus of this one is the authentication part. So if you feel that this is confusing, you can check it out. So we did return the list of all users. Now the only thing left to do for us is just get one user. It's mainly the same, but instead of only getting the claims, we are also getting the ID, and the rest of the logic is kind of the same. So we get the ID from the request and the claims, just same as we did in here. So if the request is made neither by an admin nor by that same user, we won't authorize that. And then the rest is like getting a user in a regular way. And now all of our controllers are done. In main, if you don't want to get the env variables, you can directly type port 8080 or 9000, which port you like. And your application will be complete. Now we can test our app, so let's go to Postman and create some users. In real life, a user can't assign its own role, but this is for the sake of learning, so it's okay to do that. And now if we press on send, we see the user was created successfully. If we go check in our terminal, we find status 200. Let's create an admin. I'm just keeping the same password, it doesn't matter. It's successful too. So let's have the email and try to log in. Login works too. Since this is an admin, we can get the token and display all users. To add the token, you go to authorization and you choose bearer token. And here you pass the token. Yes, I have a lot of users stored in here, not just 2 users. Let's go get a user ID and display just that one user. You can also see that the password is hashed. We can get the user ID, put it around here, get the bearer token of an admin, and we get also that one user. But if you try to access with this token, we get an unauthorized error because it's not an admin. So thank you very much for watching, and I will see you in another tutorial.